Good morning, students. So in our last class, from the exercise 6.5, from question number 2, the first question we complete, isn't it? And the first question is fx equal to modulus of x plus 2 minus 1. This one already you have done. And in this question number 2, what you have to do? We have to find out the maxima and minimum values without using derivative. So already we know how to solve. So now here we have to continue this exercise and continue this question number 2, the second question. The second question is given gx equals to minus modulus of x plus 1 plus of 3. So the procedure is same. So if you see the second question, first of all, the function is given gx equal to, if you see here, gx equals to minus of modulus of x plus 1 plus of 3. So first of all, one thing we know, modulus value, if we take only the modulus x plus 1, already we have done these questions, this type of questions. So that's why you see this one here. First of all, we know the modulus values are always positive. So that's why at first we have to write modulus of x plus 1 is greater than equals to 0. Because modulus value, that means positive. It may be 0 or more than 0. So multiplying both sides by minus. If you multiply both sides by minus, then automatically the sign will be changed, and then we get minus modulus of x plus 1 is less than equals to 0. For every here x therefore written, actually it is not therefore, x belongs to R. Is it clear? So now here to balance this result, we add plus 3 on both sides. So when we add plus 3 on both sides, then gx equals to, we get minus of modulus of x plus 1 plus of 3 less than equals to 3. Is it clear? So that means here this minus modulus of x plus 1 plus of 3, in place of this one we write gx, and then we get gx is less than equals to 3. Here directly written. So gx is less than equals to 3 means what? The maximum value of gx is 3, but minimum value we don't know. So that's why here written the maximum value of g is attained when this modulus part, that means modulus of x plus 1 equals to 0. If it is 0, then we get the maximum value. So that's why modulus of x plus 1 equals to 0, or simply we get here x equals to minus 1. Is it clear? So this x value we have to put on the given function. Given function means which one? Gx. So in place of x, if we put minus 1, g of minus 1, then we get minus modulus of minus 1 plus 1 modulus plus 3. Then after calculating this one, g of minus 1 equals to, we get 3. That means from here what we get, the maximum value is 3, but the function g does not have a minimum value because we can't predict what is the minimum one. Is it clear? Okay. Now after the second question, if you see the third one, now the third one is a trigonometric function. hx equals to sine twice x plus 5. Now the function is this one. Since we know trigonometric function, especially the sine function, always lies between minus 1 and 1. So that means the minimum value here, sine twice x given, but we know the minimum value of sine is minus 1 and the maximum value is 1. So that's why here we write, we know that minus of 1 less than equals to sine twice x less than equals to 1. Is it clear? Because the value of sine is lies between minus 1 and 1. After writing this one, now if you see, we need in the given function to balance this result, we need plus 5. So that means here what you have to do, whatever we write here, minus 1 less than equals to sine twice x less than equals to 1, in this equation we add 5 on both sides. If we add 5 on both sides, then we get minus 1 plus 5 here less than equals to sine twice x plus 5 less than equals to 1 plus 5. And after calculating this one, we get 4 less than equals to sine twice x plus 5 less than equals to 6. So in place of sine twice x plus 5, what we can write? We can write hx. So that means the hx value is lies between 4 and 6. So that means from here easily we can say here the minimum value is 4 and the maximum value is 6. Hence, so that's why here the conclusion is written. Hence, the maximum and minimum values of h are 6 and 4 respectively. Maximum value is 6 and the minimum value is 4. Is it clear? Okay. Now next one, number 4. If you see the question here, fx equal to modulus of sine 4x plus 3. No problem here. First of all, we have to check out the trigonometric function and which one is sine 4x. Since we know the trigonometric function always lies between minus 1 and 1. So that's why we have to write at first we know that minus 1 less than equal to sine 4x less than equals to 1. And after writing this one, now to balance this result we need plus 3. So adding plus 3 on both sides. After adding plus 3 on both sides, the left hand side we get 2 and the right hand side we get 4. Minus 1 plus 3, 2, 1 plus 3, 4. And now here if you take the modulus on both sides, modulus of 2 is 2 and here we write modulus of sine 4x plus 3 and modulus of 4 is 4. And now in place of modulus of sine 4x plus 3, what we can write? We can write fx. So fx is lies between 2 and 4. That means from here easily we can say the minimum value is 2 and the maximum value is 4 respectively. So that's why here the conclusion is written here. Hence the maximum and minimum values of f are 4 and 2 respectively. Is it clear? Okay. Now if you see the question number 5. The question number 5 is given hx equal to x plus 1 where x here written therefore actually it is not therefore x belongs to minus 1 and 1. So here the condition is given. In earlier cases we consider for real numbers because their condition is not mentioned, but in this case the condition is given the value of x is lies between minus 1 and 1. So that's why here minus 1 and 1 and minus 1 and 1 both are excluding here open interval, is not it? So that means the open interval concept is what? The open interval concept is in between. So that's why minus 1 and 1 is not included here. So in between minus 1 and 1. So that's why here written here if a point x naught is closest to minus 1. So as close as to minus 1 we consider a point which one is x naught. Then we find x naught by 2 plus 1 and is less than x naught plus 1. That means you see here x naught by 2 simply if we consider a number 1 and 1 by 2, which one is greater? So obviously 1 is greater, isn't it? So if you see the left hand side, here we write x naught by 2 and in right hand side we write x naught, and in both cases we write plus 1 plus 1. So which one is greater? So obviously here x naught plus 1 is greater, isn't it? So now in this case we write the left hand side we consider a point x naught and in the right hand side again we consider another point which one is x1. So in both cases we consider 2 points. So if you take another example, suppose in between minus 1 and 1. In between minus 1 and 1, simply if you consider in between minus 1 and 1 any point, suppose 0. If we take 0, for example, then in place of x we can write 0. So if we write 0, then hx equal to what we get? 1. So 1, we can't say anything here in case of 1 because hx equal to 1, not greater than or less than. If greater than less than we can say there whether it is maximum or minimum. But if we get equals, then we can't say anything because minus 1 and 1, in between minus 1 and 1 the 0 is lies. If you put 0 in place of x, then 0 plus 1 1. so hx equal to 1. So that means we can't say here whether it is maximum or minimum. So that's why the conclusion is what here, hence function hx has neither maximum nor minimum. Understood this one? So this one mathematically written like in this way. The basic concept is this one. In between -1 and 1, if we consider a point 0, and if we put this 0 on the given function, then hx equal to 0 plus 1 ultimately 1. So 1 is neither maximum nor minimum, because here not greater than or less than condition we get. Is it clear? So that's why it is neither maximum nor minimum. So I hope all of you understood these 3 or 4 questions. So today we complete the question number 2. So in our next class we have to continue this exercise and we start from question number 3. Is it clear? Okay. Thank you.